Okay, Assalamualaikum and good day everyone. So today we are going into the second subtopic, which is the trends in some key periodic atomic properties. So for this subtopic, it will be divided into two videos. Okay, so it's quite long, probably because dia just ada banyak fakta, ada banyak ayat. Okay, so you have to read a lot. And also to be able to memorize it, I think it will be so much better if kamu fahamkan sebenarnya konsep yang kamu akan belajar in this particular subtopic. Okay, so let's have a look at the learning outcome for this video. So by the end of this lesson, so you should be able to describe the variation in atomic radii. Atomic radii ni merujuk kepada size of the atom. Okay, so kita akan tengok dalam dua bentuk. One is across period, but we are going to have a look at only period 2 and 3, and we are going to have a look at the down the group as well for group 1, 2, and 13 to 18. Okay, so you will be learning something new here, which is effective nuclear charge and also shielding effect. Okay, so the next one, you should be able to compare the atomic radius of element to its corresponding ionic radius. Maksud kamu akan compare atom kepada ion dia. Okay. Alright, so variation in atomic radii. So the size of atom, it is quite difficult to be defined because orbital kalau kamu pergi balik in previous topic, orbital ni dia macam cloud tau. Okay, so bila dia macam cloud, there is no definite, macam hujung dia tu tak ada satu definite shape dekat situ. There is no clear boundary there. Okay, so because of this, so it's a bit hard untuk kira sebenarnya size of atom tu berapa. Okay, so to solve this, atomic radius is taken as half of the distance between the nuclei of two adjacent identical atoms. Maksudnya, kita akan tengok gambar. Okay, so let's say kita ada atom A. So atom A tu, so ini adalah atom A. So this is another atom A. And then kita akan letak dia side by side. Okay, and then kita akan ambil the distance between one nucleus to the next nucleus. Okay, so lepas dia dah ambil dia punya distance tu, nanti dia just bahagi dua lah. So dia akan jadi radius of the orbital. So basically inilah. Okay, so radius tu adalah bersamaan dengan the adjacent distance bahagi dengan 2. Okay, so what we can say here is the size is basically directly proportional to the volume. Okay, meaning if the size is big, therefore the volume is also bigger. Okay, and then kalau kita tengok pula volume punya untuk spherical, volume untuk spherical kan, so it is V equals to 4/3 pi r cube. Okay, so from this formula here, we know that volume is directly proportional to the radius. Okay, so betul lah, ada kaitan lah kan. Kalau volume increase, bermaksud size pun akan increase juga. Kalau volume decrease, bermaksud size pun akan decrease. So radius pun akan decrease jugalah kalau macam tu. Okay, so now we have to know what are the two major factors affecting the size of atom in periodic table. So the first one is what we call as the effective nuclear charge. So we are going to have a look at this later on. Okay, so dia ada formula dia, whereby ZEF, okay, so Miss just panggil ni ZEF lah. Okay, ZEF is equals to Z minus S. Okay, where Z is, by now you should know that the Z is proton number. Okay, and then S ni pula apa dia? Okay, so let's have a look at what is S. So S is the number of electron in inner shells. Okay, so let's say kita ada period 3, elemen dalam period 3. Elemen dalam period 3 dia ada 3 shell kan. So number of electron yang bahagian inner shell adalah the one yang dalam shell number 1 and also shell number 2. So kita kena tambahkan all together, itu considered sebagai S, number of electrons in inner shells. Okay, so nanti kita just tolak proton number minus the number of electrons in inner shell. So that is basically the ZEF. So dia ada value dia lah. Okay, and then the second one is the value of the principal quantum number, N tu. Okay, N value tu. So itu yang dipanggil sebagai shielding effect dekat sini ataupun screening effect lah. So two main factors that affects the size of an atom in periodic table is basically effective nuclear charge and also the shielding effect ataupun screening effect. Okay. So what is effective nuclear charge? Okay, ataupun ZEF tu sebenarnya, what is it? So this is the definition of the ZEF. It is the net positive charge of a valence electron experience. Okay, so as a result of shielding effect by the inner electron. So you know how nucleus dekat bahagian tengah-tengah kan, and then dia ada banyak shell. So elektron tu, kalau elektron yang paling dekat dengan nucleus, bermaksud attraction forces between the nucleus and also electron dekat situ paling kuat. Tapi bila kita pergi dekat shell nombor 2 dah, okay, adakah elektron dekat shell nombor 2 akan rasa benda yang sama macam yang elektron dekat shell nombor 1? Okay, so of course dia berbeza because of the distance. Okay, so the attraction forces, bila distance makin jauh, so attraction forces pun makin berkurang lah. Okay, so what about kita punya valence electron? Okay, so kalau valence electron, imagine shell yang paling luar, dia lagi jauh daripada di nucleus. So lagilah apa yang dia rasa sebenarnya towards nucleus jauh berbeza lah, okay, compared to the one yang dekat. Okay, so basically kita nak tahu apa sebenarnya ZEF ni is actually the net charge felt by the valence electron. Okay, kita fokus on the valence electron sahaja. So the electrons moving around the nucleus, they do not experience the same nucleus attraction. Okay, macam Miss cakap tadi, the one yang dekat dengan nucleus, attraction dia kuat. Tapi as we go further, okay, kalau value n tu makin increase, so lagi jauh dia dengan nucleus, bermaksud the attraction forces become weaker. Okay, so the electrons closer to the nucleus, they experience greater nucleus attraction. Okay, meanwhile the one that is far away from the nucleus, they experience less nucleus attraction. Okay, so that is ZEF. Okay, so kalau kamu faham konsep ZEF ni, so you should be able to boleh macam figure out lah whether the size is actually bigger ataupun smaller. Okay, and then the effective nuclear charge, okay, which is the positive charge felt by electron. So macam tadi Miss dah tunjuk kamu formula ni kan, so ZEF equals to Z minus S. Okay, so kita akan nanti kita tengoklah apa dia yang satu lagi factor tu, which is the screening effect. Okay, but now let's have a look at the variation of atomic radii across period. So across period ni we go from left to right of the periodic table. Okay, so as we go left to right of the periodic table, so what happened to the size is actually dia akan menurun. Okay, so the size become smaller. So why exactly the size becomes smaller here? Okay, so which particular factor affects the size bila kita tengok across period? Okay, so across a period, what happened is proton number increases. Okay, by now you should know that after all the periodic table, the elements in periodic table, they are arranged in increasing order of period proton number kan. Okay, so as we go from left to right, so the proton number increases. Okay, and what's going to happen here is the ZEF is also increases. Okay, and then the forces of attraction between nucleus and the valence electron become stronger, so electron are pulled closer to the nucleus. Okay, so bila attraction forces kuat, so dia akan makin rapat lah. So bila attraction forces kuat, nucleus tu akan tarik elektron tu pergi dekat dengan dia, so the size will become smaller. Okay, so that's why the atomic size decreases. So basically class, kalau kita fokus dengan point yang nombor 2 ni kan, ZEF ni, dia bagi tahu proton number increase, so the ZEF is also increases. Maksud kat sini, kalau ZEF meningkat, okay, so ZEF is basically directly proportional to the attraction forces. Okay, attraction forces between nucleus and valence electron. Okay, so ZEF ni dia macam value, macam rating tau. Okay, kalau rating yang macam rating kebersihan sesuatu hotel, so let's say rating kebersihan sesuatu hotel tu tinggi, 10 out of 10, So of course, people are more attracted towards that particular hotel compared to another hotel. Let's say the rating of the hotel, dia punya kebersihan is only 7 out of 10. So less people will actually book the hotel. Okay, so some people dia akan compare benda tu kan. So macam tu juga konsep ZEF ni. So lagi besar value ZEF tu, bermaksud attraction forces tu makin kuat. However, the smaller the value of the ZEF, so attraction forces tu pun jadi makin berkurang. So bila attraction forces antara nukleus yang dekat tengah-tengah orbital tu tadi dengan valence electron yang berada dekat bahagian paling luar tu, so bila attraction forces dia lemah, so adakah nukleus tu akan attract the electron towards itself dengan kuat? Tak. Okay, since dia dah lemah dah, so that is why kalau ZEF dia rendah, therefore the size will become bigger then. Okay, so the way kalau kita nak hafal ni, okay, lebih kepada hafal point apa yang kita nak kena mention. So yang ni kita akan guna konsep PISAS. Okay, PISAS, where P is the proton number. Okay, and then the Z is the ZEF. Okay, and then A is the attraction forces. Tapi kelas, jangan just simply letak attraction forces. You have to make sure your sentence is complete. Attraction forces between nucleus and electron. More specific, valence electron. Nucleus and valence electron. Okay, ataupun forces of attraction between nucleus and valence electron. Okay, and then last kali S is about size lah. Okay, size of the atom. Okay, so kalau proton number increase, therefore the ZEF pun akan increase. The attraction forces also become stronger, so the size of atom become smaller. Okay, so kalau yang sebaliknya, it's going to be the other way around then. Okay, so make sure all these 4 points kena ada lah if we are discussing about the variation of atomic radii in across a period. So make sure benda tu berada dalam period yang sama. Okay, jangan compare period 2 dengan 3 pula. No. Okay, yang tu bukan across period lah. Okay, for example here, okay, yang ni Miss nak tunjuk specifically in terms of value ZEF tu. Sebenarnya ZEF tu sendiri kamu tak perlu kira pun. Okay, yang penting adalah untuk kamu tahu adakah the ZEF value increases ataupun decreases going like across the period. So for example, let's have a look at this. This is atoms in period 3. So we have magnesium, aluminium, silicon and also phosphorus. So if we write down the electronic configuration, so kalau untuk kita punya magnesium ni 1s2, 2s2, 2p6, 3s2. So remember how the formula of ZEF just now is Z minus S kan? Okay, where the Z is ini proton number. Okay, yang 12 gas itu, yang 13, 14, 15 untuk phosphorus. Okay, so kita nak kena figure out the S then, where S is the number of electron in the inner shell. Okay, so untuk kita punya elements yang dalam period 3 ni 1, 2, 3, bermaksud dia ada 3 shell. So the one yang dekat bahagian dalam is electrons in period 1, electrons in shell 1 and also shell 2. Okay, so this part here, the one yang dalam bracket tu, dalam kotak tu, those are the electrons in inner shells. Okay, so kalau kita tambahkan, okay, so kalau untuk kita punya magnesium ni 2 plus 2 plus 6 bermaksud ada 10 electron inner shell, inner electron, okay, yang dekat dalam inner shell. So sama juga dengan somehow yang lain pun sama jugalah. Okay, ada 10 juga. Jadi now we know the value of S. Okay, so we can look for the ZEF. So 12 minus 10 dapat positive 2. So 13 plus minus 10 dapat positive 3 and so on. Okay, so as you can see class, betul kan tadi statement dia, proton number increases because going down dekat sini we can see that the proton number increases kan. So same goes to the ZEF class. Kalau kamu tengok ZEF ni pun, ZEF pun increase juga. Okay, going down kita boleh nampak yang ZEF to increase. So betul lah bila proton number increase, ZEF pun akan increase. And then what happen next? Attraction forces between nucleus and valence electron will also become stronger. Okay, therefore what happened to the size? So as you can see here class, what happened to the size here? So the size become smaller, kan? lagi ni. Kamu tengok ZEF untuk phosphorus ni positive 5. The atomic radius is 128. Okay, meanwhile magnesium dia punya ZEF is only positive 2 compared to positive 5 kan. So as you can see, the radius is bigger compared to phosphorus. Okay, because dia punya attraction forces kat situ dah lemah dah antara valence electron dengan nucleus. Okay, so do you have to know how to calculate this? Not really, but you need to know the formula lah at least. Okay, for you to be able to know how kamu akan dapat value ni, kamu kena faham dulu formula ni apa dia sebenarnya. Okay, so the higher the value of ZEF, the stronger the nucleus attraction towards valence electron. Okay, and then next kita tengok pula down the group. Okay, so kalau going down the group, okay, so what happen is the principal quantum number increases. Betul lah kan? Going down the group, kita start with period 1, and then period 2, period 3, period 4, period 5, and so on. So as you can see, the principal quantum number increases. Okay, the end value increases. So the screening effect pun increase juga. Apa sebenarnya screening effect ni? Lepas ni kita tengok. And then the distance between the valence electrons and nucleus are larger. Because, let's say kita ambil element from period 2. Dalam period 2, kita ada 2 je shell. Kan? Jadi bermaksud, the valence electron, dia berada dekat shell nombor 2. Okay? So yang kacau is only the one yang shell nombor 1. Tapi let's say kita ambil element in period 4. Okay, so ada period 4 bermaksud ada 4 shell. Okay, so our valence electron akan terletak dekat shell number 4. Okay, so itu valence electron. Tapi as you can see dia terhalang oleh 1, 2, 3. So sebenarnya the inner shell is actually what we call as the screening effect ataupun the shielding effect. Shielding kan, shield tu adalah penghalang. Okay, so sebenarnya the inner shell is considered sebagai shielding effect ataupun screening effect. Dua-dua boleh diguna pakai lah mana-mana je. Okay, so that is why the distance between the nucleus yang kat tengah-tengah tu tadi dengan let's say yang period 4 tu tadi, valence electron berada dekat shell number 4 kan, so the distance become larger. So what happened to the attraction forces then? Okay, so the forces of attraction becomes weaker between the nucleus and also the valence electron. So the atomic size increases then. Okay, sebab dia tak akan tarik dah. So dia jadi jauh sangat. So bila dia dah jauh sangat, so the size becomes larger. Okay, so if period tadi we have P-SAS kan. So untuk yang down the group pula we have N-SAS. Okay, N SAS. So N tu Miss guna N kecil lah. So N dekat sini adalah the principal quantum number ataupun the period actually. Okay, meanwhile S pula next one is the screening effect ataupun the shielding effect. Mana-mana cak. And A of course again sekali lagi it is attraction forces. Okay, attraction forces between valence electron and nucleus, and last kali kita ada size of the atoms. Okay, so what happened here? So kalau going down the group, what happened to the principal quantum number class? Dia akan increase. Okay, so what happened to the screening effect then? The screening effect pun akan increase jugalah. Sebab lagi banyak shell bermaksud lagi banyak inner shell. Kan, kalau ada 7 shell, I mean like in period 7, bermaksud ada 7 shell, bermaksud ada berapa banyak inner shell yang dia ada? Dia ada 6 inner shell. Lagi banyak penghalang. Okay, so kalau kamu ada dalam period tu ada 2 je shell, bermaksud yang menghalang adalah yang nombor 1 je. So ada 1 je penghalang dia. Okay, so itu adalah screening effect. So bila screening effect meningkat, therefore the attraction forces will become weaker. Okay, so kalau kamu perasan kelas, bila Miss mention pasal attraction forces, Miss guna sama ada stronger atau weaker. Okay, so make sure you use the right term lah. So what happened to the size then? The size become larger then. Okay, so larger, so ni increase. Okay, so the screening effect ataupun shielding effect, it is the electrons in inner shell shield the electrons in outer shell from the nuclear charge. Nuclear charge dekat sini is actually the proton in the nucleus. Okay, so that is proton actually nuclear charge tu. Okay, So going down the group, the atomic radius of element increases. So as you can see here, so this is example for the one in period. This is the one in group 1. Okay, so semua ni group 1. Okay, so semua ni adalah group 1. It's just that yang ni adalah the one in dalam period 2, and then yang sodium dalam period 3, potassium in period 4, and rubidium pula in period 5. Okay, so as you can see, as we go down the group, the number of inner shell pun meningkat juga. Okay, macam yang Mr. explain tadi. Okay, so this is basically the trend going down the group. So this one here is group 17. Meanwhile yang atas ni pula adalah group 1. Okay, so going down the group, as you can see, the size become larger. Okay, so the size becomes larger. So ini pun becomes larger. But then kalau kita compare antara group 1 dengan group 17, okay, so the group 17 is basically smaller lah. Okay, because kalau one dekat sebelah kiri, 17 dekat sebelah kanan kan. Kalau kita tengok going across the period tu, memang kita nampak smaller lah. So that's why kamu boleh nampak ni, basically group 1 ni lagi besar size dia secara generalnya lah. And then kalau group 17 lagi kecil size dia. Itu adalah untuk period lah. Okay, tapi in this particular case here, it shows the one yang down the group. Okay, so kita focus on this one here is group 1, yang bawah ni pula adalah group 17. So the graph shows that going down the group, the size of atom increases, so it becomes larger. So conclusion, the size of atom going down the group, the atomic radius increase. Okay, so ini ada kaitan dengan yang ansas tu lah. Okay, so dia ada kaitan dengan the principal quantum number. Okay, and then dia ada kaitan dengan attraction forces. So ada kaitan dengan size next then. Okay, so basically, so nilai yang berlaku kan. Okay, dia makin besar kalau kita pergi ke bawah. So kalau cross period pula, the atomic radius decreases. Okay, it becomes smaller. So this is because of the ZEF. Okay, the greater force of attraction between the valence electron and also the nucleus. So that is why the atomic radius becomes smaller. So ni gambar aja je lah. Okay, kalau yang ni sebenarnya, kalau Miss gabungkan the two triangle together, it is like bendera di atas bukit. Okay, yang ni adalah bukit dan kita letak bendera dekat atas tu. Yang ni yang going across the period, yang ni yang going down the group. So kalau going across period, kita guna apa tadi dia punya points? Points dia adalah pizzas. Okay, kalau kita going down the group, kita akan guna ansas. Okay, so just remember the points lah. So kena ada semua point ni, and then baru macam okay, betul. Betul kamu nanti. Okay, so tapi Mrs. nak bagi tahu sometimes size ni, sebab size ni untuk both of the dua-dua bahagian ni kan, size ni Miss letak last sekali kan, tapi sebenarnya kalau size tu adalah benda pertama yang kamu discuss dahulu, and then last sekali tak payah adalah letak size. Okay, so S ni boleh berada dekat bawah sekali, last sekali point yang kamu nak discuss, but it might be the first one yang kamu nak discuss. Okay, okay, so basically this is the value of atomic radii for our elements. Okay, so kalau kita tengok lithium, beryllium, boron, semua ni sampailah neon, they are in the same period. So you can see that the size becomes smaller. Meanwhile, yang lithium, sodium, potassium ni, they are in the same group. So going down the group, the size becomes bigger. Okay, so semua kamu kena adalah point dia masing-masing untuk kamu discuss nanti. Alright, so the next one pula adalah kita nak compare the size of atom to its ion. Okay, for example, sodium atom kita nak compare dengan sodium ion, ataupun oxygen atom kita nak compare dengan oxide ion. Okay, so by now you should know that if cation, meaning dia release electron kan, cation yang positively charged particle. Meanwhile the one yang negatively charged particle, anion, dia gain electron. Okay, so kena faham konsep tu. Itu yang paling penting sekarang ni. So baru kamu boleh try figure out, try tengok, try untuk fahamkan points yang kita akan tengok lepas ni. So among cation and its corresponding atom. So cation is formed when we lose electron. Okay, macam saya cakap tadi. So when electrons are removed from the valence electron, the mutual repulsion decrease. So talking about repulsion now. Before this, we talk about the attraction forces. Okay, we talk about attraction forces between nucleus and also valence electron. Kenapa ada attraction forces kat situ? Because nucleus ada proton dalam tu. Proton charge dia adalah positif. Meanwhile, electron pula charge dia adalah negatif. So positif berjumpa negatif, that's why dia ada attraction forces. Okay, but here we are talking about the mutual repulsion. Mutual repulsion between apa? Tadi attraction forces between nucleus and valence electron. Now we're talking about mutual repulsion. It is about mutual repulsion between electron. Kenapa dia repel? Because negative and negative. So of course they repel lah with one another. Okay, so bila kita hilang satu elektron ni, so that's why dia kata the mutual repulsion decrease. So it allows the remaining electrons to be pulled closer together around the nucleus due to the greater nucleus attraction. Okay, so that's why cation, they are smaller than the atoms from which they are formed. So for example, kalau kita ada magnesium ion, it is actually smaller than magnesium atom. Okay, kalau kamu tak dapat nak imagine ni, kamu imagine kamu duduk dalam bulatan, a group of 5 people. Okay, so kamu buat dalam bentuk bulatan, but let's say one of your group member, dia dah balik, dia balik bilik ke apa. Okay, so now what's going to happen to your bulatan dan? Ada space dah kan? Betul tak? Ada space, satu space yang kosong tu kan? So apa yang kamu akan buat sekarang? Kamu akan kecilkan bulatan tu, kan? Okay, so sama juga konsep ini. So bila elektron tu kita remove, so that is why dia cakap kat sini, the remaining electrons, they are to be pulled closer together around the nucleus. Sebab dia punya repulsion tu dah berkurang dah. So that's why dia akan makin dekat together. Okay, so Miss rasa kamu dah mungkin boleh expect kot what's going to happen to anion. So will anion be larger than the atom? Kita akan tengok lepas ni. Okay, so basically ini adalah comparison. Okay, where you can see that all the atoms is the one yellow color. Yang ion dia pula is the blue color. So as you can see, the ion, okay, cation, dia lagi kecil daripada dia punya atom. That is because they remove electron. Remove electron, the mutual repulsion between electrons decrease. Okay, so points yang kita kalau nak cakap kat sini adalah, kamu kena cakap dahulu, kalau pasal ion lah, kamu kena cakap dahulu loses electron ataupun dia gains electron. Okay, and then we are going to talk about the mutual repulsion between valence electron. Okay, and then next barulah kamu boleh cakap pasal size then. So it's quite simple. Okay, so point dia a bit berbeza compared to yang kita compare between elements yang ada in the same group ataupun in the same period. Okay, and then now we are going to compare the anion to its corresponding atom. Okay, so now anion meaning dia akan gain electron kan. So dia receive electron. So imagine pula tadi kamu ada, sekali lagi kita guna 5 orang tadi. Okay, 5 orang. So kamu ada a group of 5 people duduk dalam bentuk bulatan, but then tiba-tiba ada datang lagi 2 orang kawan kamu nak join. Okay, nak join lepak sekali. So apa yang kamu akan buat sekarang ni kelas? Kamu akan, yang group 5 orang tu tadi, dia akan try bagi space lah kan, dia akan tolak kawan-kawan yang lain supaya yang 2 lagi tu boleh masuk dalam bulatan tu. So what happens to the bulatan then? It's gonna be bigger. Kan kamu pergi tolak kawan-kawan lain tu tadi, bermaksud what happened to the mutual repulsion? Mutual repulsion increases. Okay, so when more electrons are added to the same shell, the mutual repulsion increases. Okay, between electron and electrons. So that is why they will be like pushing far apart with one another. Okay, dia akan tolak. So the nucleus attractions become weaker lah, because kamu dah tolak tu tadi, kamu makin jauh. Bila makin jauh, the attraction forces sebenarnya makin weak. Okay, so that is why the size of an ion, they are larger compared to the atom. Okay, so for example, if kita ada oxide ion is actually larger than the oxygen. Okay, so these are comparison between ion and the atom. So the atom is the one in yellow color, the anion is the one in green color. So as you can see, the green one, they are larger compared to the atom. Okay, so konsep yang sama juga kamu discuss tadi lah, cakap pasal elektron tu kamu gain kah ataupun kamu lose elektron, and then talk about the mutual repulsion. Okay, so and then sebenarnya kena cakap juga pasal distance between the electron and also the nucleus. So apa jadi dengan size tu nanti. Okay, so now this is a try this question. So you have to choose the largest atom from each of the following group. Okay, and then explain your answer. Okay, so ada 3 group dekat sini. Tengoklah. Try to figure out whether they are in the same group kah ataupun they are in the same period. If they are in the same period, kita cakap pasal across period. So guna point PISAS. If we are talking about elements in the same group, and then kita kena talk about the ANSAS then. Okay, so try to figure that out. And then this is another one. So dalam Miss punya ni tak clear sangat. I mean like dia hilang pula huruf dia. Tapi I think dalam your notes sepatutnya ada PQR ni. Okay, so these 3 elements, they are isotope. Sekejap. No, they are not isotope. So this is isotope notation for the 3 elements PQR, and then you have to determine the group and period for element Q and so on. I think yang ni okey je kot. Okay, sebenarnya soalannya berkaitan dengan topik kita hari ni adalah yang B je sebenarnya. Okay, but try jawab ni semua ni. Yang ni semua ada kaitan dengan yang in previous subtopic juga sebenarnya. Okay, and then number 4. Okay, tak apa. Nanti kamu try sendiri untuk yang ni. Okay, so kita settle untuk yang learning outcome yang A. Okay, kita dah compare the atomic size between taklah, kita dah habis dah sebenarnya. Kita dah compare the size, the atomic size across a period and also down a group, and then we also have discuss on the size of atom. Kita compare dengan ion dia, kan? Sama ada anion dengan atom dia ataupun kan dengan dia punya atom dia. Okay, jadi in conclusion kan ni? Yes, betul, conclusion. Okay, so conclusion across a period, so meaning there are more proton. Okay, meaning the ZEF is also increases, so that is why attraction forces between nucleus and also valence electron become stronger. Okay, so that's why the size becomes smaller. Meanwhile, down a group, the principal quantum number increases. Okay, so the electron become more further apart from one another, so less attraction. That's why they becomes larger. Okay, kalau kita compare at cation pula, so talk about the hilang electron ataupun gain electron. So next one kita talk about the repulsion, mutual repulsion. So in this case, hilang electron, so less repulsion then. So that's why dia jadi smaller. However, for anion, since they gain electron, so more repulsion, dia akan tolak, therefore they becomes larger. Okay, cuma Miss nak pesan, bila kamu tulis dalam kamu punya explanation, so explanation tak perlu dalam bentuk essay lah. Kamu boleh buat dalam bentuk point. Macam ANSAS tu tadi kan ada 4 point. Boleh buat point. Okay, tak perlu buat semuanya dalam satu paragraph. And one last thing yang Miss nak pesan adalah, kalau macam okay, kalau dalam apa ni tadi? Kalau dalam kamu punya explanation, so let's say ZEF ni, jangan simply tulis ZEF. Okay, you have to mention first effective nuclear charge dalam kurungan ZEF. Itu okay. Okay, so the first time kamu nak mention pasal ZEF, you have to write down the full meaning of the Zef first, and then baru kamu boleh the next one bila kamu nak ulang balik pasal Zef tu baru boleh guna Zef je. Okay, sama juga dengan N ni pun sama juga, you have to mention about the principal quantum number dahulu, dan kalau nak ulang lagi dan baru boleh guna je simbol N. Okay, jangan terus simply guna dia punya abbreviation dia. Alright, okay, itu sahaja. Thank you.